section in the textbook, you see if there is a specific section in the textbook that has the answer that you think is fit to answer that question. You read it through, then if you're lucky enough, you find that the answer is direct there. Then you pick that answer as it is, you rate it when answering your question. Kezia, please stop playing with our document. Let me first work on those settings as well. Okay. So then you go on like that. Now, when you find a question, like maybe look at now, like for example here, part B, give 2 disadvantages of using a transmission electron microscope. Now, even if you have an idea of what the answers could be, remember, you have gone to read, to revise, you've gone to read, you've not gone to do an exam, you've not gone to do an exercise. So what you do, even if you see that the question is asking for 2 disadvantages of using a transmission electron microscope, now what you do, you look for your notes. After looking for your notes, then you open in the notes, do I have anywhere where you have an electron microscope? If you find it in your notes, then you say, do I have disadvantages and advantages here? But if you see them, then now you read through all the advantages, you read through all the disadvantages. Then after that, then you pick out 2, because the question wants 2. You pick out 2 and you rate them. You transfer them from your notes onto your summary book where you're answering the questions from. Even if they look obvious, you take time and write them down. That time you spend writing down is enough to make sure that you comprehend the question very well, and you also comprehend and understand why that particular answer. Then after writing your 2 answers, then you can do, then you say, now that question is done. Then you go to another question. Explain why, for example, explain why scanning electron microscope produces more detailed images of cells than a light microscope. Then you open your notes. You see where they are talking about electron microscope. You read it through. You read it through to see if there is any clue or if there is any hint that will enable you answer a question like this one. Then if you find it, then you write it down. Now, if you fail to locate the answer and you try to think, still you can't figure out what the answer is, then now that's when the teachers come in. That's when the teacher come in. The teachers come in. You go to the teacher, then you ask for the help of the teacher. You say, teacher, I found this question, I failed how to answer it. How can it be answered? Then now the teacher will guide you. Now the teacher can guide you either by giving you the exact, or still the teacher will just give you an interpretation or an approach, and maybe direct you to where you can find the answer. Now, if the teacher directs you to where you can find the answer, take time, go to that textbook, open and read it. By reading through, you are even understanding more things that are beyond this question here. In that, in the future, when you find a question still related to this, then it will be easier to recall that, oh, I was making research to the question in the textbook, I read this and this and that. Like that. Then you go through the whole question and finish it. Then after finishing the whole question, then now you can say that at least now I have revised the topic of cell biology. Or maybe still you had even opened the notes. Then now you can even remind yourself, when you open notes, you can remind yourself of the things that you had even forgotten, or of the things that you had taken long without reading in those notes. Then after reading through, then now you go back, you go to your next question. That is how we read. It is very dangerous to read only the notes without using questions. That method does not work. You'll forget things. By the time you close the book, chances are high that you might have forgotten each and everything. I'll give you an example. Let me try to open another document which has those notes. Then let me look for my notes. They're here. Okay, so I hope my document is coming through, the one which has the notes. So here we have cell structure, the introduction of cells. So remember, when you open, for you're looking for a specific answer. For instance, let us now look at number 41, part A. Number 41, part A is saying, explain why a scanning electron microscope produces more detailed images of cells than a light microscope. Then you go to your notes where they're talking about the electron microscope. The microscopes are here. The electron information is here. So of course, I will not read through to look for the answer, but now for you read through. Now, when you read through, if you find that there is a clue to what the answer might be, then you write it. For instance, let me see if I can identify where the answer could be. Electron microscope, you see, has high resolving power. It is that one, an advantage. Has high resolving power and has a high magnifying power. So that is where my answer could be. Either because it has a high resolving power or because it has a high magnifying power. So that is where the answer could be. Now, I'll put the question back to you. Why do you think a scanning electron microscope produces more detailed images of cells than a light microscope? The clue is in the word detailed. So, and we have two options. Let me actually simplify your work. We have two options. We have answer A has a high resolving power and answer B has a high magnifying power. One of these answers, if given, is wrong. So what do you think is the correct answer? You can put up your hand or you can write inbox. Let me first read the responses inbox. Others are saying some of us are in senior 6 and yet you're talking to form 6s. Oh, no, even it is for A level. This seminar is for A level. Senior 5 and senior 6, please. Senior 5s don't go as long as you do biology. That's why even I think you have already covered that topic of cell biology. So I'm going to get questions of the topics that they have already covered, but also if I get the questions from other topics, just take note of the skills, the interpretation skills that we shall be using. Someone is asking later on, you clarify on amylose and amylopectin. These are the things which are direct in the notes. Okay, we shall talk about them. Are we gonna able to access the recording? Yes, the recording will be out. Has a high resolution. That is good. All of you inbox are telling me that it has a high resolving power. And that is the correct answer. So the correct answer here is that because it has a high resolving power. Who can tell us why is the magnifying power not a correct option? By show of, if you have the answer, you can put up your hand. Queen Patricia, unmute.
Okay, good afternoon, everyone. The reason why the answer of magnifying is wrong is because the question is talking about more details. And that is the definition of resolution, whereby we say it's the ability to distinguish between two separate objects which are close. So that's the resolution. But magnification simply is how much larger an object appears. Know how much larger an image appears compared to the object, but the detailed bit is because of the ability of the microscope to distinguish between two objects.
Okay, thank you so much. Patricia has explained it so well that I don't even want to repeat what she had said. But there is a very big difference between resolving power and magnification. With magnification, I can, for example, you have phones, smartphones. You can take a picture. And when you take a picture, you try now to magnify that picture. Now, you magnifying that picture, actually, the more you magnify it, the more the details are distorted. You find that, yes, you have a magnified image, but when the details are distorted or when the details are not clear. Okay, then part B is saying give two disadvantages. Now, when you're reading and you find a question like this one, for you, don't struggle yourself, don't burden yourself. Go straight to the notes, and when you go straight to the notes, look for where those disadvantages are. For example, now in the notes, if you have these notes, this would now be the area to read. Now, you take time about 5 minutes, you read through everything. You read through the advantages, you read through the disadvantages of electron microscope, you go to the advantages, you go to the advantages like that. Then after, you pick out only two that the question demands, then you write it down. So that is how we revise. That is how we revise. Otherwise, don't pick out the notes for cell biology and say that now today I'm going to read cell biology. You read, but at the end of the day, when they ask you a question, you find that you may not even be able to answer even the smallest or the easiest of the question from that topic that you claim have been reading from. Okay, then we have part C there. So I want someone to work out part C. Work it out. Then you tell us the formula that you have used and how you have arrived to the final answer. 2 minutes. Then another person should be working on the main ideas of the cell theory. Let me open the chat room. Now Bainom Jisha is asking that can the answer of resolving power alone weigh 2 marks? I think we need to explain. Yes, you're right. Even the question, let me go back to the question. Even the question is saying, explain why a scanning electron microscope produces more. Even the question is saying, explain. So now, should we really be worried about the marks? Let me first get all the questions in the chat at once, then we do them at once. Then Julie was saying it is not concerned with detailing things. Yes, that is true. It is not concerned with detailing things. Then question, please, I think. Okay, that's all in the chat room. Okay, so now here, when you say that because it has a high solving power. Now, actually what you have done when you say has a high resolving power, you have just stated why, but you've not explained why. So the explanation is in briefly how the electron microscope works. That is where the explanation is. So now you have to tell us briefly, how does the electron microscope work? The technology it uses that enables it to have that higher resolution or higher resolving power. Of the electrons used. That is where the explanation is. That these scanning electron microscopes, they always use shorter wavelengths of electrons. Okay, sorry for that. Yes, Rooney. Rooney, you can unmute yourself now.
I was saying that I was giving the answer for my gamification. So as you can see, the question is says that the width of the watch of the cell is 6.5 centimeters, and the actual width of the watch of the cell is 130. So for me, I first converted 6.5 centimeters into what? Okay, it's like 6.5 times 10,000 watts micrometers. Then I got my answer as what? 6,000? No. Yeah. 65 watts thousand as my answer, micrometers. So I again came back to the actual width. So actually what I did, I said in 65,000 over 130.
So what the 65,000 is coming from where?
I changed the centimeters into micrometers.
You change centimeters into micrometers, so that you can have the same units.
Yeah, the same units.
Okay. Yeah, thank you. Actually, that is what we had to do. Now, it means that now, when actually you're reading, you realize that now you need to know the conversions of these units, centimeters and millimeters. And in most of the notes, those conversions are there. The conversions are there. If they're not there in the notes you're using at school, understanding biology has those conversions.
Okay, Sam, is my question correct? Or...
Pardon?
Is my answer correct?
Yes, your answer is correct.
Okay, Sam.
Okay. Teacher, I thought we multiply by 1,000. Yeah, now it takes us now to the conversions. Okay. So that question calls you for the understanding of how conversions are made. How many micrometers are in a centimeter, etc. Someone is asking for more examples about that number. Okay, other examples, you can write these. So you can write down these questions very fast. Write those questions very fast. I'm giving you 3 minutes for trial. These are the questions that can come either in objectives or they can still come in section B. So I'm giving you about 3 minutes. Write down those questions. Then you try them out in your free time. Also, if you can, write those conversions. And those conversions you must know by head. So you see, these are the things that sometimes you think they may not happen. For example, if the teacher is teaching and they don't give you trial questions, you may just think, even you may never know the applicability of these conversions here. But when you're using questions, then you learn to know that, oh, it means I have to know these conversions by head. We must have finished. Someone saying, what is the magnification of? The formula of magnification. The formula of magnification is there. Write it. That is the formula we use for magnification. Okay, then now you must have finished. We now go back to our question. So, what are the main ideas of the cell theory? Now, here the question is asking for the ideas, the main ideas of the cell theory. Another way of phrasing this question, they can ask you to state the cell theory. Or they can ask you to explain the concepts of the cell theory. These things they can ask you to do. Still, you don't have to burden yourself. Since you're revising, you go to the notes, open the notes and see where you can get that information and you read there. And this is what we are talking about. These ones here, the cell theory. These are the points behind the cell theory. And they are always there in the notes. Let me first also check in the chat room. Teacher, with us some of the papers for practice plus those notes we are using in the WhatsApp group. Ryan, I've not understood whether it is supplement, whether it is a question. I've not understood your point. Okay. Okay, the notes will be shared. The notes will be shared in WhatsApp group. It's fine. Okay. So now, when you finish a question like that, then now you have to make sure that you now use this opportunity to look at, to peruse through the topic of cell biology and remind yourself perhaps of what you had gotten. If you're in senior 6, it means that you last learned these things last year in March there. So now it is a full year. Then now this is now the time you take to read through or to peruse through all the topic and remind of yourself what you have forgotten, what you had forgotten. So that is how we revise biology. Okay. Then someone is asking for pardon on the conversion. Now, those of you are saying that you're not in the WhatsApp group. The way you access the link to this seminar is the way you'll access those notes. Okay. Okay, then now we can now proceed. So now those ones in senior 6, you now have a task. And what is the task? Before you sleep today, remind yourself of the topic of cell biology. Okay. Then now, let us now go to another question. So that is how we can read things or we can revise topics that may not have questions on graphs. Let us now go to another question. Another question, I'm now going to target the one which has graphs. Like this one. Now this one is from the topic of gaseous exchange. I know senior 5s may not have covered this topic, but take note of the skills, take note of the concept, how questions are answered. That is what we are here for. We are not here to understand the questions and to cram the answers. We're just here to get the skills that we need to answer questions. Okay. So it is the question. Now, this graph can come in paper 1. It can as well come in paper 2. Whichever paper it comes in, the answering is the same. But it will always be more harder in paper 1 because paper 1 will require you to be brief and precise. That is what paper 1 will require you to be, brief and precise. So, what do we now need to understand this question? I always tell my students that whenever you find out data questions, first read through the introduction of that graph carefully and see if there is any new word that you don't understand. Before you proceed, make sure you understand the introduction. Then after that, you now start generating your own hypothetical questions and the answers as well. Then after that, you go now and interpret the graph and see if your interpretation is actually in line with what is presented on the graph. So let us also try to understand, even those ones of senior 5. I'm sure by the time we start answering, you'll have understood where we're coming from. So the question is saying the graph below shows an adult human who was given various gaseous mixtures to breathe, and the rate of breathing was measured. Now, what is the task here? It means that now you have to ask yourself, think of how was this experiment done? And can you do it yourself? And if you do it, what would be the aim of you doing that experiment? So here they're telling us that, first of all, we have an adult human who was given mixtures of gases to breathe. So it means that now they had different mixtures of gases, and they presented these different mixtures of gases to this adult human to breathe. And as this adult human was breathing, then they measured the rate at which this human was breathing. So that is what they did basically. Now, the task here would be, for now, what we have mentioned so far, do you understand? Are you starting to understand how the experiment was done? And have you started to think of the outcomes, actually, the results? So, how many mixtures do we have here? We have 3 mixtures. We have mixture A, we have mixture B, we have mixture C. What is in mixture A? 90% oxygen, 10% carbon dioxide. So it means that now they gave this person a mixture which has 90% oxygen and 10% carbon dioxide. Then they gave person B normal atmospheric air. But now, because they are giving us here these mixtures with gases in percentage, they now have to start asking yourself, what is the normal percentage of these gases in atmospheric air? So that is the mixture that they gave this person. So it means that now mixture B has about 21% oxygen and 0.03% carbon dioxide. So that is what is in mixture B. Then what of mixture C? Mixture C are 100% oxygen. So mixture C has only oxygen, 100%. Then what of carbon dioxide? So it means that now carbon dioxide is 0%. So it is 0% of carbon dioxide. Then now, can we now try to establish the trend? In every data that you see, always try to establish the trend. So what is the trend here? With oxygen, this is the average, medium, this is very high. Then with carbon dioxide we have 10%, 0.03%, 0%. So carbon dioxide concentration goes on decreasing from mixtures A to C. And remember, when we are teaching this topic of gaseous exchange and even transport, the rate of breathing in the human body is not determined by how much oxygen you have in your body, in your blood. It is determined by how much carbon dioxide you have in your blood. That is what determines the rate at which we breathe in. If you have a lot of carbon dioxide in your blood, then this carbon dioxide will trigger an increase in the rate of breathing so that you can breathe faster and expel that much carbon dioxide. It is never oxygen that determines the rate of breathing. And also, when we are teaching this topic, there is a point where we teach control of breathing in humans, how the rate of breathing is controlled in humans. The rate of breathing in humans is controlled by the brain. It is controlled by the brain. And in the body, we have those sites that keep on monitoring how much carbon dioxide is in the body, or they keep on monitoring the level of carbon dioxide in the body. And one of those points is the carotid body. The carotid body is on the carotid artery keeps on monitoring the blood that is passing through that artery. If blood passing through that artery has a high concentration of carbon dioxide, then that one, the carotid body, is now going to send impulses to the brain. Then the brain will now send impulses to the lungs, causing these lungs now to increase the rate of breathing. Then the person will breathe faster. So we're just trying to get some clues that we shall use when answering this question here. Then now, let us now interpret the data here given to us. Here we have time in minutes. Then here we have rate of breathing. So we can notice that in mixture A, when the person was given mixture A to breathe, the rate of breathing was so high. So it means that now mixture A increases the rate of breathing. Then when the person was given mixture B, this is normal atmospheric air. You can see that the rate of breathing kept on decreasing gradually with the time. It kept on decreasing. So it means that now mixture B did not increase the rate of breathing, but rather it slightly reduced it with the time. Then what of mixture C? Mixture C, we can see that mixture C further reduces the rate of breathing. Mixture C, that's what we can see. It further reduces the rate of breathing. So now we start now asking ourselves, why? Because even if you've not yet read the questions that follow, they must ask you, why is that the case? So now you start now developing your own hypothetical questions. Why is it that mixture A increases the rate of breathing and mixtures B and C reduce the rate of breathing? Then why is it that mixture C, which has 100% pure oxygen, further reduces mixture C further reduces so we can see also you have to ask yourself a question, why is it that mixture C further reduces the rate of breathing? Bearing in mind that mixture C has 100% oxygen. So those are the things that we should be asking ourselves. So maybe if I may put the question back to you, why do you think, even from what I've explained so far, why do you think mixture A increases the rate of breathing? Why? And mixtures B and C gradually reduce the rate of breathing. Why? I can see hands somewhere. Somebody should be able to unmute yourself now.
As at first you said that it is carbon dioxide that stimulates the rate of breathing. And when we look at mixture A, is having much carbon dioxide compared to mixture B and C. That's why the rate of breathing goes on reducing.
Okay, thank you. Patricia, what do you think? Patricia, you can unmute yourself.
Okay. In A, the rate of breathing increases because the composition of mixture A is made up of a higher percentage of carbon dioxide than the normal carbon dioxide. So the increase in carbon dioxide in the blood is going to stimulate the receptors, the chemoreceptors, which send impulses to the medulla, to the inspiratory center in medulla.
Yes, Patricia, go on.
So, okay, the issue is that mixture A has a higher percentage of carbon dioxide than the normal in atmospheric air. Therefore, the carbon dioxide concentration in blood increases. This stimulates the chemoreceptors in the carotid and aortic bodies to send impulses to inspiratory center in the medulla. So impulses from medulla to the phrenic and thoracic nerves, then to diaphragm and external intercostal muscles, respectively, will cause increased rate of contraction, leading to faster inspiration. Therefore, the rate of breathing increases.
Okay, thank you. Yes, Patricia, thank you so much. Rooney, what about you?
So, like you said, yeah, that the rate of breathing in the body is being like it is considered by the concentration of oxygen in the body, in the blood. So because by the percentage of carbon dioxide in the blood. So because the concentration of carbon dioxide in blood is higher, and
Yes, Prince, go on. Okay. So, yes, it is true. It is about the concentration of carbon dioxide because we have already established a trend of carbon dioxide. That carbon dioxide keeps on decreasing from A, B, and C. So mixture A, because it has a high concentration of carbon dioxide. So this high concentration of carbon dioxide in the body will trigger the brain, the respiratory center of the brain, to send impulses to the rib cage or to the lungs, stimulating them to increase the rate of breathing. That's why we see with a decrease in the concentration of carbon dioxide, also the rate of breathing keeps on decreasing and decreasing. Okay, so let me also go inbox. Okay. Yes, the responses in the group are good. Okay, so it means that now we now have an idea of how this data was generated, and we all agree that what is in this data can actually be explained. We all agree with that. Okay, so now let us now look at the questions. Now, whenever you're interpreting these graphs, never proceed to read the questions unless you have understood what the question really wants you to do. So what the experiment is all about. So now I'm assuming that we now know what this experiment is all about. So let us now look at the questions that we are going to answer. So that is question 1. What is the effect of carbon dioxide concentration on the rate of breathing? So that is the question, that what is the effect of carbon dioxide concentration on the rate of breathing? Now in biology, when they ask for a question, they phrase that what is. In most cases, they are not interested in the explanation. They're just interested for when you look at the question, what is the effect of this? Don't give that because of this and this, just you look at the data, then you realize the effect. So they're asking, what is the effect of carbon dioxide concentration? So from this graph, when you look at it, what is the effect of carbon dioxide concentration on the rate of breathing? Yes, Chilama?
It increases the rate of breathing.
That is wonderful. Samuel? Maria? Maria, come up again.
Increase in the rate of carbon dioxide concentration leads to the decrease in the rate of breathing.
That is wonderful. So from the graph, we can see that, of course, we have now established our trend. We can see this is high, followed by B, which is 0.003, followed by C, where we have 0% carbon dioxide. So it means that now an increase, one person can say a decrease in carbon dioxide concentration results into an increase. So it also results into a decrease in the rate of breathing. Another person can say an increase in carbon dioxide concentration results into an increase in the rate of breathing. But again, remember, the question is saying, the question has 2 marks. So, and we really want to we're not really sure whether you know the concentration of carbon dioxide in atmospheric air and the concentration of carbon dioxide in mixture C. So now for you to get those 2 marks, you have to first tell us what is the concentration of carbon dioxide in mixture A, mixture B, and mixture C. Then after establishing that concentration, then you now give us your trend that you have picked from the graph. Because in the graph, it is not direct that from A to C, the concentration of carbon dioxide keeps on decreasing. It is not directed. And that is what we want you to identify out and tell us. So it means now for you to get those 2 marks, you have to first identify out, give us that concentration. Then after giving that concentration, then you now establish the trend. Then you now tell us how this trend is affecting the rate of breathing. That is what this question wants. Let me first see in the chat. Okay. Okay, there's okay. So what would I have written here? Of course, you would say, because remember, you're answering the question that what is the effect of carbon dioxide concentration on the rate of breathing? So I will say that mixture A has 10% carbon dioxide concentration. Mixture B has 0.03% carbon dioxide concentration. And mixture C has 0% carbon dioxide concentration. Therefore, from mixture A to C, the concentration of carbon dioxide is decreasing. And from the graph, the rate of breathing decreases from A to C. I can give it that way. Or I can say, therefore, the rate of breathing is decreasing with decreasing concentration of carbon dioxide from mixture A to mixture C. So I must also see the trend of the concentration of carbon dioxide in your answer, that the trend is from A to B to C. So that is how the thing is. Now people are asking, what if they ask to describe? Describe. What is the problem with the describing? You describe. For mixture A, you describe it. From 0 to 1, gradual. From 1 to 2, rapid. From 2 to 3, gradual. From 3 to 4, constant. Then mixture B, from 0 to 4, gradual. Even mixture C, gradual. Then uniqueness would come in if they ask you to compare. If they ask you to compare, then you compare that mixture B. If they now ask to compare mixture B and mixture C, you just say mixture C decreases less gradually than mixture B. Or another person can say mixture B decreases more gradually than mixture C. There's nothing difficult with it. You just look at it and describe as usual. Someone is asking the concentration of carbon dioxide in mixture B. They're saying it is normal atmospheric air. Now, what is the concentration of carbon dioxide in atmospheric air? That thing you should be knowing. Then, now let us go to part B. As of part B, they're saying, with the reference to the graph, explain why mouth-to-mouth resuscitation is a better means of artificial respiration than pressing on the chest wall. Wow, what a question. But they're saying with reference to the graph. So you have visualized the graph. This is the graph. Just look at it once again. Now, that part B, what do you think is the answer? 2 minutes, think about it. Now, I'm seeing some funny questions in the chat room. Now, please, one of the things that makes biology so hard is you trying to imagine questions that do not exist. Every graph has questions that can be set from it. So when you look at a graph, don't now start imagining things that what if it is like this? What if it is like that? What if it is like that? If you can't explain it, you yourself, then it means that they can't ask you that. It means that now that science is wrong. That way of thinking is wrong. So let us first answer these questions the way we have them. Then if you're not confident, then you can now start adding on other questions in your free time and you see if you can answer those questions. Otherwise, you stop imagining questions that do not exist. There are some questions they cannot ask you from this graph. They are there, those questions that they can't ask you. What is the trend? What is what? Don't imagine those questions. All graphs are not answered in the same way. Just focus on this one and you try to understand how we are interpreting it. Then if time allows, we also find another graph, then let us also focus on that graph at a time. Binomial juicer is saying because it is faster and easy to use. Ojulong is saying mouth-to-mouth respiration facilitates provision of a higher concentration of carbon dioxide, which increases on the rate of breathing of the person being given the first aid. Ojulong has a point here. Ojulong is saying that mouth-to-mouth resuscitation facilitates provision of a higher concentration of carbon dioxide, which is true. Because remember, mouth-to-mouth resuscitation, the person is literally breathing out, breathing in the air that you have breathed out. Because you put your mouth on the mouth of another person and you start blowing the air into that person's mouth. So it means that the air you're blowing into the person, to you, is the air that you have breathed out. So it means that now that air is actually containing a higher percentage of carbon dioxide than the normal atmospheric air. Then Joash Blair is saying, I think that during mouth-to-mouth resuscitation, the person gives more carbon dioxide, the person which induces more breathing. Yeah. That is also correct. Because from the graph, we have seen that with the more carbon dioxide, then the rate of breathing increases. We have seen that from the graph. So here, Blair is saying that during mouth-to-mouth, the person gives more carbon dioxide. Of course, now, you also have to clarify which person here. Otherwise, we may assume that the person of the patient. So here, the person doing the first aid gives more carbon dioxide to the person breathing in or to the patient, which will induce more breathing. Yes. Then Sharon is saying, pressing on the chest aimed at decreasing lung volume, hence increasing pressure, hence initiating expiration. Sharon, your response is not clear. Remember, we are saying that actually mouth-to-mouth is the better option than pressing on the chest. So using evidence from the graph, we are explaining why do we think it is the better option. So that's what the question is about. Then in Joseph Jolie is saying, I think mouth-to-mouth breathe, a patient gets more carbon dioxide, hence increasing the victim's rate of respiration than on pressing the chest. Yes, that is wonderful. So I'm happy with the responses from the chat room. Then let me also look at those ones who have raised their hands. Yes, Ignatius.
Right, thank you, Mr. Arthur. I have one question. I think I can also go to my view on this, but the question, they told us reference to the graph. I would think if I can give those reasons to put something there from the graph, like comparing and saying concentration carbon dioxide, and then now having a higher concentration of carbon dioxide expired, which pressing
Ignatius, sorry, you're breaking. You're breaking. Your network is not clear.
saying that, not hearing me now.
No. Ignatius, sorry, we can't hear you at all. Your network is breaking. Actually, I didn't hear anything from what you're asking. So maybe you can send it inbox. You send it in the chat. I'll read it and be able to respond. So here is the science. Because before you answer any question, you have to first think of the science behind it. Then after thinking of the science behind it, you get your facts right. Then after getting your facts right, then now you see how you're going to rate your answer. And in your answer, all your facts must be included. All your facts must be included in your answer. And remember, this is paper 1, summary rating skills. So the science is simple. From the graph, we can see that the more carbon dioxide we have in the mixture, the higher the rate of breathing. So it means that now if a person is given mixture A at first, of course at 0, this person's rate of breathing will start to increase gradually after 1 minute. Then the person now starts breathing faster and faster. Then when you reduce now on the concentration of carbon dioxide to atmospheric percentage, which is 0.03, is it 0.003? Then you notice that now, actually the person's rate of breathing decreases gradually. Then when you give the person a mixture without any carbon dioxide, the rate actually reduces further and further and further. And this is actually very dangerous. The person may eventually die. Because if you're breathing at a slower rate, it also means that tissues, the body will receive less oxygen. So that the body may receive much oxygen, but the rate at which it will expel out the carbon dioxide will be slow. So you may die due to oxygen poisoning. Actually, it is called oxygen poisoning. So it is very deadly to breathe in pure oxygen, very deadly. It's like giving yourself an overdose. Or it's like giving an electrical appliance excess current. It will blow. So it means that, and then we now look at what they're using here. With mouth-to-mouth resuscitation, you are literally blowing into the mouth of this person air that you yourself you're breathing out. Means that now the air you're putting into the body of this person has a higher percentage of carbon dioxide. Then when you press on the chest wall, yes, when you press, the pressure in the chest wall keeps on changing. And this person will actually breathe. This person will take in some air. Because when you press on the chest, the pressure in the chest increases. Then when you release the pressure on the chest, then the pressure inside will increase. Then this person will now be able to suck in oxygen, suck air into the lungs. So you keep on doing that and doing that. So which one is a better option? When this person receives too much carbon dioxide in the body, then the carotid body and the carotid body will now detect it, will detect the high concentration of carbon dioxide in the blood. And it will now send information to this person's brain. Remember, this person has collapsed. This person is not breathing, he has collapsed. So the brain will now be stimulated, send impulses to the lungs, so that now the lungs can wake up and start breathing by themselves. And when now the person wakes up and starts breathing rapidly, that is what you wanted, because you just wanted this person to breathe. So it means that now mouth-to-mouth resuscitation enables the person to recover faster. Because when you're breathing into the person's mouth, you're breathing in air that is containing a high concentration of carbon dioxide. And from the graph, it is shown that when you increase carbon dioxide concentration in the air, the rate of breathing increases. So that is what we are seeing there. Okay. Then Margaret is saying, how does pressing the chest bring about artificial respiration? So Margaret, I hope I have answered you. Margaret, because you're asking that how does pressing the chest bring about artificial respiration? I have said that when you press on the chest, you are changing the pressure and volume in the chest cavity. Remember, how do we breathe? We keep on changing the pressure and the volume in the chest cavity. When the pressure in the chest cavity increases, then the volume reduces. Then air is sucked, air is expelled. Then when the chest volume increases, when the chest volume reduces, then the pressure will increase, then air will be expelled. Volume increases. When the chest volume increases and the pressure reduces, then air will be sucked into the lungs. So by pressing on the chest, you're trying to bring about those pressure changes, which also works. It actually works. It works. So when you see your colleague collapsing, if for one reason or the other, you don't want to do mouth to mouth, then you can keep on pressing on the chest. It also works. But though it is a slower mean of recovery, people would recover faster when you do that mouth to mouth resuscitation. So I hope, Margaret, I have answered you. Then Cyprian is saying the first person will give more carbon dioxide to the person breathing, hence increasing the rate of breathing. That is correct. Ryan Ignatius is saying, my question, in hospitals, more often than not, we had people say that the person has been put on oxygen. So I want to understand, is the person given oxygen or carbon dioxide? So more clarity on that mechanism, and also tell us the name of that device. I thank you, teacher. Well, now, when in the hospital, when you know that the person is put on oxygen, now, in those oxygen cylinders, they also put in other inert gases. That cylinder is not purely oxygen. Pure oxygen is deadly, is very dangerous. So in those cylinders, the biggest percentage of gases in that oxygen cylinder are inert gases. Gases like nitrogen. Then the other portion is the oxygen. They may not put their carbon dioxide. So in the hospitals, that is what they give. In those cylinders, it is oxygen and some other inert gases. So Ignatius, I hope I have answered you. Then Rooney is saying, isn't that method dangerous to the patient? Now, I don't know which method, but all the methods we have mentioned are not dangerous. The only dangerous thing I have said is giving a person, or the most dangerous thing I've said is breathing in 100% pure oxygen. But the other methods, mouth-to-mouth resuscitation and the pressing on the chest, they are not dangerous. They are involved, you see it in films, they practice them. Then when someone has got a cardiac arrest, what they do, they just come and people pressing on the chest. Why? They want the lungs to inflate and deflate and press against the heart so that the person can now recover. Then Joseph is saying, what if the person finds as a result of effect of the burning charcoal stove in a room, his mouth is still the best option? It is still the best. Why? You want this person to start breathing by themselves. And the cause of fainting, the cause of a charcoal stove in a room is not the carbon dioxide, but it is the carbon monoxide that is released when the carbon burns in limited supply of oxygen. So the fainting is because of the carbon monoxide and not the carbon dioxide. Then Rooney again is saying, the chest method, doesn't it harm the patient? No, it doesn't. Joseph, is there a difference between kiss of life and mouth-to-mouth breathing? I'm not so sure, but I think kiss of life is more to people who have drowned in water. You want to suck water out of their lungs. You want to suck water that is blocking their trachea. You want to suck out water that is blocking their throat. So you do a kiss of life, mainly to suck out the water that is blocking their respiratory pathways. But with mouth-to-mouth breathing, here, you're just trying to help the person who is not breathing recover. Then Sharon is saying, what's the role of those inert gases if they cannot trigger respiration as carbon dioxide do? Now, the role of the inert gases is still to make sure that the person does not breathe in 100% oxygen. That is the role of those gases. They want to make sure that when you breathe in, at least you're not breathing in 100% oxygen. They want to make sure that you take in very little oxygen at a time, because too much oxygen is deadly. Then Cyprian, sir, why when a fish removed in water suffocate? And now people are now taking us into other things. But nevertheless, the whole of it is biology. Now, fish removed from water would suffocate because of one thing. The gill filaments are many. Therefore, they provide a larger surface area for extraction of oxygen from the water. Now, when you remove the fish from the water, the gills would collapse. So when these gills collapse, then the gill filaments will stick together. Now, when these gill filaments stick together, then they will have reduced the surface area for absorption of oxygen. So the fish will suffocate because it is not able to take in enough oxygen into its body because of the reduced surface area of the gills as a result of their collapsing when you get them from the water. That is why the fish suffocates. Then somebody is saying when the lesson is ending, the lesson will end at exactly 5. The lesson will end at exactly 5. Then Margaret, elaborate on the point of carbon monoxide causing fainting. Well, now, carbon monoxide causing fainting, still, this is biology that we teach. And you'll learn these things in a topic called transport in animals. With the transport in animals, you'll learn how hemoglobin transports oxygen and also how hemoglobin transports carbon dioxide. Now, that hemoglobin, when it combines with the when it combines with oxygen, it eventually dissociates to release the oxygen once it reaches the tissues. But this same hemoglobin that combines with oxygen to transport it can also combine with carbon monoxide. The difference is that when now the hemoglobin combines with the carbon monoxide instead of oxygen, the complex that is formed is permanent. Carbon monoxide does not easily dissociate from the hemoglobin. So hemoglobin will not be able to go and carry more oxygen as it will have already got itself bound onto the carbon monoxide, and this carbon monoxide is not leaving. So the person faints because the tissues are not receiving the oxygen. Why? Because all the carbon monoxide is now carrying all the hemoglobin is now carrying carbon monoxide, and carbon monoxide is not letting it go, so that this hemoglobin can go again and carry the oxygen. So that is the point of carbon monoxide causing fainting. Teacher, pardon the dangers of breathing 100% oxygen. Now, also in the topic of respiration and gaseous exchange, we have these things, the dangers of breathing in pure oxygen. So those things, if you've not reached this topic, when the teachers reach there, they'll give you these dangers, but they are there in the notes. And these are the questions that we ask. Even there is a year, I'm forgetting, you never asked to outline dangers of breathing in pure oxygen. So they are there in the notes, don't be worried. But one of them is that it results into damage of cells. The cells get damaged. So the too much oxygen eventually damages the cells. How? The cells will produce a lot of ATP, and this ATP will eventually burn or damage these cells. It's like you're giving the bulb too much electricity than it needs. However much you know that the bulb needs electricity to light, but it has a limit. If you give this bulb much electricity, it will blow out. Then another problem, another danger is that it can lead to permanent blindness. The retinal cells in your eyes are very sensitive concentration of oxygen in the blood. So when they receive too much oxygen, those retinal cells will be damaged and someone is likely to go blind. But you'll find more in the notes. Then Blair is saying, I think that a fish suffocates because it takes in dissolved oxygen, which is missing in the atmosphere. Now, that reasoning is not correct. If you say that a fish suffocates because it takes in dissolved oxygen, but remember, when they bring fish at home, when you check the gills, those gills are still moist. They are still moist. The fact that they are moist, it means that they can still get oxygen from the atmosphere. Oxygen in the atmosphere will dissolve with that moisture on the gill surfaces, and this oxygen will diffuse into the gill filaments, and the fish will now get the oxygen. So it is about collapsing, sticking of the Gill filaments, and reducing the surface area for gaseous exchange. Then Ryan is saying more idea on why the fish dies when drawn out of water. That one, I think I've now repeated it. I've explained it. Teacher, may I have your number? Thank you, teacher. Okay. So my number, you can ask for some things on WhatsApp. My number is the one I use on WhatsApp. You get somewhere to write. Is 0701 36 6474. That is my number. I'll repeat it once more again. 0701 36 6474. I respond faster when you send a WhatsApp message, because you may call when I'm busy and I may not attend to you, but at least for WhatsApp, even if it takes a day, eventually I would respond. So don't call. Okay, let me put it in the chat. Most people are saying they can't hear. Okay. So the number is sent in your inbox. You can check there. Okay. So that is that for that part B. So you have now understood the science behind it. And now ask yourself, sit down and write an answer that befits that section B. Then let us now go to part C. Part C is saying, explain the dangers of rebreathing expired air if it is first passed through soda lime. There is also here another problem. Now, for you, when you find such a question, don't panic that hey, the question is hard. First, break it down into pieces. As you interpret it, ask yourself, why this? Why that? Then at the end of the day, you add those dots together and come up with the concrete explanation. Now here the thing is like, explain the dangers of rebreathing expired air. Now for you, you first pause there, that dangers of rebreathing expired air. Then now you ask yourself a question, what is in expired air? You know that expired air, this because remember, we are still on our graph. All these questions, you go back to your graph to see if you're still on point, or to see if you can get some clues from the graph. So expired air, maybe if I may ask you, what is in expired air? What is in expired air? Someone is saying carbon dioxide. Yes. Carbon dioxide mainly. That is good. So it means that now in expired air, we have carbon dioxide. That is what we have. Others are saying air without oxygen. So those ones we are asking for the paper that we are using, I have shared it in your inbox, so you should be able to download it. I've shared that paper in your inbox, you download it. Okay. Nitrogen, carbon dioxide, air that has already been inhaled. I thought there is some carbon dioxide in expired air. Water vapor, then low concentration of oxygen. Okay. Well, now, what is in expired air? The expired air is the air that you breathe out. So it means that now expired air actually contains a high percentage of carbon dioxide than atmospheric air. That is expired air. It contains a high percentage of carbon dioxide than atmospheric air. That is the first fact. Then, what of absorbing it, putting it in the soda lime? So Daniela has sent something in my inbox that if the expired air is passing through soda lime, the carbon dioxide will be absorbed and only oxygen will then be present. It will be having a lot of oxygen, which can lead to oxygen poisoning. Partly yes, partly yes. But then no. Daniela, that is not correct because it doesn't mean that the percentage of oxygen will keep on increasing and increasing. Where is this oxygen coming? Remember, it also has more other inert gases. We will always tend to suppress the percentage of oxygen. Then Ojulong is saying soda lime removes carbon dioxide from the expired air, which reduces the carbon dioxide concentration, which is true. The air causes a reduction in the rate of breathing. Oxygen supply to the body tissue reduces. Yes, Ojulong has a point here. Let me read Ojulong's response again. Ojulong is saying that soda lime removes carbon dioxide from the expired air, which reduces the carbon dioxide concentration. The air causes a reduction in the rate of breathing. Oxygen supply to the body tissue reduces. Very true. Yeah, actually, I even feel like stopping here because he has given us the answer which I've been looking for. So others, I hope now you have known why, even if I don't read other responses. Because now you should also ask yourself, what is the role of soda lime here? Soda lime absorbs carbon dioxide. So it means if you absorb carbon dioxide from the air, the person will now keep on breathing in the air, which is having little carbon dioxide. But remember, at the same time, the oxygen is reducing in the tissues. Because remember, expired air, it has a high percentage of carbon dioxide, but at the same time, it has a low concentration of oxygen because most of the oxygen has been retained by the body. So here is this person. The person is taking in air. First, the air is containing little oxygen. Then secondly, this air is not having carbon dioxide. Now, and remember we said that it is the carbon dioxide which stimulates or which triggers breathing. So the body will not be able to detect that you are breathing in the air with little oxygen, because the body only realizes that you're breathing in air with little oxygen when the carbon dioxide in the body increases. That is when the body gets to know that, oh, you see, if carbon dioxide has increased, then it means this person needs oxygen. Now let us increase the rate of breathing so that the person can now take in the oxygen that we need, but at the same time, we remove this excess carbon dioxide. Now the body will not be able to trigger that change. Then the person will eventually die. Why? The person will die due to lack of oxygen or to limited supply of oxygen in the tissues. Why? Because the person's body would not detect the declining concentration of oxygen because of the absence of carbon dioxide that triggers breathing. So that is the logic behind it. So it is not about breathing pure oxygen, because even remember, in expired air, we don't have oxygen almost. We have a very small percentage of oxygen compared to atmospheric air. Because remember, when you breathe in around 21% atmospheric oxygen, what you breathe out, you can breathe out around 16% of the gas containing oxygen. So oxygen is still there, but it is in limited supply. The concentration is very little. Okay. I hope it is clear. Okay. So we can proceed. So now that you have known the science behind this part C, also again, ask yourself, sit down, see if you can write an answer that is befitting that question. Biology or sciences are about practice. You task yourself to do things. And when you task yourself to do things, that is how we learn. That is how you learn. If you're lazy, you don't want to task yourself, then you're likely to always suffer with those low scores in biology. So beat that chain or break that chain of laziness. If there is a question and you have known the approach, take your time, sit down and task yourself to write now an appropriate answer, having known the idea. And when you read through the answer, also you can be convinced, you can actually know that, yeah, this answer is good or this answer is lacking something. And if you realize that your answer is lacking something, then please add it there. Okay. Someone is asking, what is the composition of soda lime? Someone is saying that they did not get the concept of soda lime. Well, soda lime, now people are asking the component. First of all, you don't need the component to know the component. But nevertheless, it is sodium hydroxide. But you don't need the component. So soda lime is sodium hydroxide. It absorbs carbon dioxide. That is the role of soda lime. Soda lime absorbs the carbon dioxide. So the question is saying, explain the dangers of breathing expired air if it is passed through soda lime. So it means that now you breathe out air, and this air you have breathed out it is the same air that you breathe in. That is this question here. You breathe out air, and then you are going to breathe in that very air that you have breathed out. It's like if you get a polythene bag, you cover your face. So if you cover your face with a polythene bag, then when you breathe out air, you are going to breathe in. Now, the air that you are breathing in is the air that you breathed out. So what they mean by rebreathing expired air. And it is deadly. Actually, you can also do that experiment. You see how the rate of breathing is increased with increased carbon dioxide concentration. When you cover yourself with a polythene and you start breathing, you notice that with the time, you'll start breathing faster. And please, if you start breathing faster, remove the polythene immediately. Otherwise, you may die. You may damage your brain permanently. It is a very deadly experiment. So you realize that you start to breathe faster. Why are you breathing faster? It means that now the air that you're breathing in has a lot of carbon dioxide. And the body has detected that there is a lot of carbon dioxide in the air that you're breathing in. Therefore, what will the body do? Now the body will now trigger an increase in the rate of breathing. So in this experiment, what they're saying that now that air that you have breathed out, that now before you rebreathe it in again, it is first passed through soda lime. So it means that now the soda lime is now going to absorb all the carbon dioxide in your expired air. Now, what are you going to breathe in again? So now you're going to breathe in air which is having very little concentration of oxygen, because every time you take that air into your lungs, oxygen is extracted from it. Then you breathe it out. The percentage of oxygen reduces. You are going to breathe it in. The oxygen that is there will again be extracted out. By the time you do that one 10 times, you're now going to breathe in air which is not having oxygen at all. Then you will suffocate and die. So that is how this experiment is done. That the air that you breathe in, one, soda lime has removed all the carbon dioxide. Then you take it in. The oxygen in it remains in the body, some percentage. Then you breathe out that air again with little oxygen and the carbon dioxide. Then it is again passed through soda lime. This soda lime again removes all the carbon dioxide. Then you are going to rebreathe in that air with a little oxygen. Now, the little oxygen in it will again be retained by the body. Then you are going to breathe out that air. It is passed through soda lime. Soda lime again removes all the carbon dioxide. Then you are going to breathe it in. So every time you rebreathe, the concentration of oxygen keeps on decreasing and decreasing and decreasing. And also, to make matters worse, your rate of breathing will also not increase. The rate of breathing will not increase. Why? Because of the absence of carbon dioxide in the body that triggers an increase in the rate of breathing. So you'll die quietly. You'll die without struggling. No increased rate of breathing, no what? You'll just pass by and die. So that is why it is very dangerous. So what you have to write here, you have to tell us that the breathing in expired air is the breathing in air. So the breathing in expired air passed through soda lime is breathing in air without carbon dioxide, because the soda lime will have absorbed all the carbon dioxide. But this air still has a small percentage of oxygen. And in absence of carbon dioxide, the body will not detect the declining levels of oxygen to trigger increased rate of breathing. Therefore, the person will suffocate and die. Okay, so someone is saying distinguish soda lime and lime water in relation to the question. Oh, now don't confuse lime water and soda lime in the question here. Soda lime detects presence. Soda lime is actually calcium hydroxide. Now, soda lime detects presence of carbon dioxide, which turns milky if carbon dioxide is present. That is soda lime. It detects the presence of carbon dioxide, but that is lime water. But soda lime absorbs the carbon dioxide. So don't confuse lime water and the soda lime. They do different things in science. Okay. So that is it. So now, what have we learned today? We have learned today that for all questions, for you to be able to answer them, first break them down and know the facts or the science behind them. Then after knowing the science behind them, then see how you can patch up those facts that you know to come up with the concrete explanation. And after, read through and see if your explanation is actually making sense in relation to the question. Then secondly, I have given you tips of how best you can read biology. And I've told you that we read using questions together with the notes and the textbooks. You read the question, you rush to the notes and the textbooks and read through to see if you can identify the answer. And if you find the answer, you write it down. So that is how we read biology. You read using questions. At times when you are very tired and you feel like not reading anything, then for you can just chill in the question bank. You get your question bank, you just start opening. You open, which year you read, just reading the questions. Just read the question, just for leisure. Now, instead of opening newspapers to read, instead of opening novels to read, instead of opening the notes to read when you're not in the moods of capturing anything, you can just always chill in the question banks. You just open the question, just to know the questions that are asked. Then the next time, when maybe the teacher mentions something in class, then for it will be easier for you to recall that you say, oh, I've ever seen a question from what the teacher is talking about. Then you'll pay attention because you know you have ever seen a question from what the teacher is talking about. Or even when you're reading notes, you may land on something, you say, oh, I remember finding a question about this one here. Now let me go back and look for the question and now see if I can answer that question. So that is how we read sciences, and especially biology. But biology is a very demanding subject. It needs smart reading and hard work. And it doesn't tolerate laziness. If you look at a question like this one and you think it is hard and you abandon it, that is the laziness I'm talking about. Biology does not tolerate that kind of behavior. Just yourself, look for the answer, look for the explanation, and you must get it. Because those who always ask questions, they always find the answer. It is people who don't ask questions that always fail to find answers. So, so this recording will be shared. It will be shared. I'm sure it will be shared. How you access the link to this seminar is the same way you'll access the recording of today's session. Okay. So it is exactly 5. I think we can end it from here. Until we meet again. Have a nice day.
Thank you, teacher.
You're welcome.
Thank you so much, Mr. Arthur.
You're welcome.
Thank you so much, Mr. Arthur. When are we meeting again?
Normally, we always draft timetables. Those timetables are weekly. So kindly you keep on checking on the how you got the link and the timetable. That is how we always work. The sessions are always the holidays, about 2 or 3. So if there is another meeting, it may be next week.
All right, thank you.
Okay, thank you, sir. But I hope you also give us another, like, apart from weekends, another week. Maybe you can also try tomorrow.
No, we have the timetable of other subjects. So tomorrow, you may find tomorrow there could be math or chemistry or physics. So today
No
was
problem. Okay, no problem. But at least I was like, every day we have a certain subject.
That is the timetable we are following.
Okay. But some of us don't have the timetable.
So how did you get the link?
It was in the group.
Now that very group tells the person who shared the link to share the timetable. There is a group which has enough students. So that's why we always post the link. So whoever sent you that link can get you the timetable.
Okay, sir.
All
right, thank you, sir.
Thanks a lot, Master.
You're welcome.